Assalamu alaikum. Hi all. In this tutorial, we are going to have a discussion on sample 1 exam chemistry for the university entrance examinations. The first question which we are going to see today is here on the screen. In which of the following substances is there no hydrogen bond formation between the molecules? To solve these kind of questions, first of all, you have to understand two conditions forming hydrogen bond. First thing, it must have Fon, F-O-N, fluorine, oxygen, or nitrogen. Any one of these molecule atom must be present in the molecule. As well, it will be directly connected to hydrogen. Okay, let's see the structure of sulfur dioxide. Sulfur dioxide, you will see S double bond O double bond O. Okay, there is no hydrogen is connected with oxygen. So the answer for this one, definitely this. Because in hydrogen fluoride, you have hydrogen directly connected to HF. See, hydrogen directly connected to fluorine. So this hydrogen fluoride molecule will make an hydrogen bond with the nearest hydrogen fluoride molecule. Whereas in formic acid, you will see that is HCOOH. Okay, here also you have OH. That means oxygen and hydrogen is being connected. So the condition, any one of these atom must be present there, and thus that must be connected with the hydrogen atom. Here this HCOOH, this hydrogen will be making hydrogen bond with the oxygen of the next molecule. Okay, so you can see here this oxygen and this hydrogen over here, C double bond O. Okay. Whereas in butanol, same, you can see it is C4H9OH. You have oxygen directly connected there. And acetamide has got the formula C double bond O CH3 NH2. So you see here nitrogen is directly connected to hydrogen here. So the condition for making hydrogen bond, remember, fluorine, oxygen, or nitrogen must be present in the compound, and that must be directly connected with the hydrogen. Okay, these are the two conditions you have to look for formation of the hydrogen bond. Here there is no hydrogen, that's what the answer. Here it is not making hydrogen bond is sulfur dioxide. Second question. The chemical formula of one of the nitrogen oxide is N2O5. What mass of nitrogen would be found in 54 grams of N2O5? You can see here, this is from the periodic table. Nitrogen, its molar mass is 14, and oxygen, its molar mass is 16. Some of the periodic table you will see like 14.01, something like that. So whatever the value which they are giving in the question, you have to use. Now, let's find molar mass of N2O5. In N2O5, we have 2 nitrogen. So let's go for nitrogen, 2 times 14. And we have 5 oxygen. So oxygen we can do 5 times 16. So this is 28 and plus 80, you'll get total of 108 grams. So 108 grams is for N2O5. Molar mass is 108 grams. Okay, this is the molar mass of N2O5. Now let us see how much of nitrogen is there in 108 grams. You see there are 2 nitrogen, so 28 grams of nitrogen is present in 108 grams of N2O5. So 108 grams of N2O5 has 28 grams of nitrogen. The question is asking for 54 grams of N2O5. What would be the mass of nitrogen? You have to do cross multiplication, or you can just see here 108 gram, half of that is 54. So 28, half of that is 14 grams. Or you can just do a cross multiplication here. 100 times x, 108 times x is equal to 28 times 54. So x will be 14 grams. So the answer here is 14 grams. Let's see the third question. What is the average molar mass of a mixture containing 3 moles of propane and 1 mole of hydrogen? See, they are asking for average molar mass. We have 3 moles of propane. Well, we can do 3 times molar mass of propane is 44 grams. So 3 times 44 plus we have 1 mole of hydrogen. So 1 time hydrogen is 2 grams, 2. So total, how many moles we have taken? 3 moles of propane and 1 mole of hydrogen, total 4 moles. So the answer for this one is 33.5 gram per mole. So the answer here is this one. Oh, sorry. 33.5, not 3 point. Don't make this mistake. You have to go for 33.5. Okay. Let's see the next question. The reaction between 1 propane and hydrogen chloride is an example of what? You see here, propane. Propane is an alkene. Alkenes are having a double bond. Any compound with a double bond, there will be a tendency to undergo addition reactions. In addition reactions, you see, this double bond will break. When the double bond gets broken, things can be added to this carbon and this carbon. So when you add hydrogen chloride, okay, this bond will break. So it will be like this. See, I'm just talking about these bonds. Double bond, one of the bond from the double bond will break. And here hydrogen will go to one of the carbon and chlorine will go to the other carbon. So hydrogen chloride added there. These kind of reactions where double bonds gets broken and the other molecules being accommodated there, we call addition reactions. Remember, any alkene like with E and E will undergo addition reactions. Let's see the next question. Aqueous sulfuric acid solution is electrolyzed using graphite electrode. Graphite electrode is an inert electrode. It is not taking part in any of the chemical reactions here. So we have to choose the correct statement. First of all, you have to know what is actually happening here. Sulfuric acid is H2SO4. This would produce the ions H plus and SO4 2 minus. These are the two ions that can be formed from sulfuric acid. As well, it is aqueous. Aqueous means it will have H plus and OH minus ions. So the ions present here, H plus, OH minus, that's from water, and H plus and SO4 2 minus, that's from sulfuric acid. You have to know anode is positive, so negative 1 will go to the anode. You have two negative ions. OH minus as well SO42 minus. Remember, if no halogens present, halogens means fluorine, chlorine, bromine, that is group 7. Fluorine, chlorine, bromine, iodine, and astatine. If no halogens present, then the preference will go to OH minus ions, hydroxide ions. Whenever hydroxide ions goes to any of the electrode like anode, 4 OH minus together will go. They will form 2H2O plus O2 plus 4 electrons. This is always happen when OH minus goes to any of the electrode. Remember this equation you have to know. Then cathode reaction would be cathode is negative, so positive ions will go to cathode. Here hydrogen is positive, so hydrogen will gain electrons to become H2. So cathode hydrogen gas will be produced, and anode you will see oxygen gas will be produced and water will form. Now once you figure out these reactions, you can go to the options. On the surface of the anode, oxidation reaction occur. Of course, oxidation is losing electron. That you have to remember in another way. An ox. Anode always oxidation. Remember this, an ox. Then cathode, you remember red cat. Red cat. That means reduction occur at cathode. Reduction occur cathode, anode oxidation. So here they are asking for the correct statement. First statement itself correct. On the surface of the anode, oxidation occur. So this is the correct one. Hydrogen gas liberated at anode. No, it's in cathode. Oxygen gas liberated at cathode. No, oxygen gas is liberated at anode. After electrolysis, H2SO4 solution becomes more diluted. No, because at the end, more H2SO4 will be remaining because H plus and OH minus has been removed. So it will become more concentrated. During the electrolysis, identical volume of gas is liberated. No, here for producing 1 mole of hydrogen, you need just 2 moles of H plus, here 4. So the gas produced would be double for hydrogen than oxygen. Let's see the next question. Which of the following gases under identical conditions contain the largest number of molecules? Just remember, in 1 mole of any gas, any substance, that will be 6.02 into 10 to the power 23. You just have to identify, or you just have to find out how many moles are here. Okay, so first of all, you have to know HBr molar mass is HBr molar mass. When you look, it is 81. Sorry. HBr is 81. How 81? Hydrogen is 1 and Br is 80. So you have to always look for the big number for the molar mass. So 80 plus 1, that is 81 for HBr. When you are looking for argon, it is just 40. For chlorine, it is Cl2. So 1 chlorine 35.5. So 35.5 times 2, that is 71 grams. And for SO2, sulfur is 32. So sulfur, you can say it's 32, and oxygen 2 times 32. So total it is sorry, oxygen is 16. So 16 times 2, 32, 32, 64 total. Now for nitrogen oxide Nitrogen, you can see it is 14, oxygen is 16. So for nitrogen oxide, the molar mass would be 30. 14 plus 16, that is 30 grams. That is the molar mass. Now what you have to do, you have to find the number of moles. How can you find number of moles? You remember this thing? Number of moles is equal to mass over molar mass. If you want to find number of moles, that is mass over molar mass. So you have mass here, that is in grams, and molar mass here. Okay, so we will be going to find the number of moles for first one. Number of moles for HBr, 100 divided by 81. So for HBr it is 1.23, and for argon that is 100 over 40, that's 2.5 moles. And for chlorine, let's do 100 over 71, that's 1.408. And SO2, that's 100 over 64, that's 1.56. And for nitrogen monoxide, 100 over 30, that is 3.3. So the highest number of moles is for nitrogen monoxide. See here 3.3. This is the highest. So if more number of moles, they will have more particles. Largest number of molecules, that you will be nitrogen monoxide. So the answer here is the last one. So what you have to do in this kind of questions, you have to find number of moles. The one with highest or more number of moles will have more molecules at that particular temperature. Next question, that's question number 7. It's about the pH. Okay, a pH is 12 solution. Select, you have to which one would be the correct for pH 12. So remember, pH of any pH is equal to negative logarithm of concentration of H plus ions. Okay, and another important thing you have to remember in this question, pOH is equal to negative log concentration of OH minus ions. Another important thing, always pH and pOH, when you add them together, will be 14. These things you have to remember. pH and pOH total 14. pH is equal to negative logarithm of concentration of H plus. pOH is equal to concentration of negative concentration of OH minus ions. Now, let's look for the first one. Of sodium hydroxide containing 0.01 mole per dm cube. Okay, so sodium hydroxide, this is an alkali, so this will be the concentration of OH minus. So concentration of OH minus is 0.01, so we can find pOH. pOH is equal to, you take your calculator, negative logarithm of concentration of OH minus. So here it is, concentration is 0.01. Negative log 0.01. That's 2. So if you have pOH is 2, then pH will be 14 minus 2, 12. Okay. So here pH and pOH is total 14. So you found pOH because this is an sodium hydroxide, it's an alkali. So this is the concentration of OH minus ion. So you first find pOH, then you subtract it from the 14 because together it is 14. So 14 minus 2, that is 12. So the answer here is the first one. Why not second? Because ammonia is a weak alkali. Weak alkalis won't decompose completely. Okay, ammonia in aqueous solution, it will be NH4 plus and OH minus. But this is a reversible one. It will not completely ionize and has concentration of H3O plus 10 to the power minus 2. That when you do the pH for this, pH is equal to negative logarithm of 10 to the power minus 2, that we get 2. And for this one, a hydroxide has an hydroxide concentration of 10 to the power minus 12. Minus 12 means it's any hydroxide. They are not mentioning as the sodium hydroxide. There are some hydroxide like calcium hydroxide. These hydroxides will produce 2 OH minus ions. Okay, so those cases it will become doubled. So it's not the answer. Acetic acid contains 0.01. Acetic acid, again, this is a weak acid. So weak acid, all the organic acids, almost all the organic acids are weak acid. So if it comes CH3COOH with COOH, you cannot take this directly. So the answer over here is first one. Let's see the next question. This one is talking about which substance is getting oxidized and which substance is getting reduced. So first of all, you have to know how to assign oxidation number for different compounds. Simple rule, oxygen is usually -2. Okay, hydrogen is usually +1. And halogens like fluorine, chlorine, bromine, iodine, that is the group 7 elements. Okay, always -1. Not always, there are exceptions, but usually. Okay, so they are -1. When you assign oxidation number for oxygen as -2, you see here 2 oxygen. So 2 times -2, that is -4. To cancel it out, manganese must have +4. Total for a neutral molecule would be 0. Total oxidation number. So here oxygen we assigned -2. So 2 oxygen, so 2 times -2 would be -4. So to make it as 0, manganese must have +4. And in HCl, Cl is from group 7, -1, hydrogen +1. MnCl2, Cl is from group 7, -1. So 2 chlorine, 2 times -1, -2. To make it as 0, +2 must be here. So +2, this -1 times 2 -2, total 0. And if a molecule is alone, if it's not combined, it's uncombined state, it will have an oxidation state of 0. And for H2O, oxygen, that you know, -2, hydrogen, that is +1. Okay, so let us see now. Manganese oxidation state changes from +4 to +2. So decreasing oxidation state is reduction. Now hydrogen, no change. Oxygen, no change. But chlorine has changed from 1 to 0. Minus 1 to 0 is an increase. 1 increased. So this is oxidation. Manganese got reduced from +4 to +2. That's reduction. And chlorine oxidized from -1 to 0. There's an increase here that is being decreased. Remember, oxidation agent or oxidizing agent is the one getting reduced. The one getting reduced. To oxidize another substance, that particular substance must undergo reduction. Okay. So oxidizing agent, you have to look for which element reduced. So MnO2, this Mn is reduced from MnO2. So MnO2, this is oxidizing agent. Oxidizing agent. Because it is getting reduced in this reaction. The one which gets reduced is an oxidizing agent. So the answer here, MnCl2. Let's see the next question. How many lead ions are contained in 2 moles of lead dioxide, whose formula is PbO2? You can see here they're asking for how many lead ions PbO2 that can ionize to form Pb2 plus, Pb4 plus and oxygen -2. So here one lead ion is being produced, right? So if you have 1 mole of this, 1 lead ion, already we have 2 moles of this. So 2 moles of this will produce 2 moles of lead ion. 1 mole will produce 1 mole, so 2 moles will produce 2 moles. But you remember how many, not moles. They are asking for how many lead ions. That means you can choose, you have to use Avogadro number. 1 mole 6.02 into 10 to the power 23 number of particles. So if you have 2 moles, 2 times 6.02 into 10 to the power 23 number of particles. That will be 1.2 into 10 to the power 24. So the answer for this question will be this. 1.2 into 10 to the power 24. Let's see with the next one. Which of the following substance has the lowest melting point? When you look at the melting point for covalent molecules, you should know the intermolecular forces. The strongest intermolecular forces present in molecular compounds is hydrogen bond. Okay. You remember, hydrogen bond will be present in the molecules having phone. Fluorine, oxygen, or nitrogen, that must be directly linked with hydrogen. Okay, this is the strongest intermolecular force. Second one is permanent dipole interaction. Permanent dipole interaction. That will be present in the molecules which is polar. And the last one is van der Waals force or London force. That depends on the size of the molecule, size of the electron clouds of the molecule. So methanol, you have to know that is CH3OH, that has oxygen and hydrogen. So this has hydrogen bond. So this will be strong. Methane is CH4. So you see here CH4. It's a non-polar molecule because its bond polarity will get cancelled out because of the symmetry of the molecule. Acetone is CH3 CO CH3. So here, because of the CO bond, this could be written like this also, CO CH3 CH3. Due to the presence of CO bond, which is polar, it will have permanent dipole interaction. Methanoic acid, meth means one carbon atom, so you have to remember that is HCOOH, again oxygen hydrogen, so it will have hydrogen bond. So this also having high intermolecular forces. So if more intermolecular force, it will have high melting and boiling point. Remember, stronger intermolecular force means high melting and boiling point. Means high melting and boiling point, you have to remember. Now, methyl acetate. Methyl acetate, you have to remember the structure for this molecule will be CH3 COO CH3. And this also hydrogen bonds won't form, but still CO bonds are there, like COO bond. This is highly polar, so PD will be there. This is the smallest molecule and which is non-polar. The polarity of the molecule is not there because of the cancellation of it due to a symmetric structure. So methane is the answer here. Remember, these kind of questions you have to look for intermolecular forces. The one with highest intermolecular force, strongest intermolecular force, will have high melting and boiling point. Okay. Among intermolecular forces, hydrogen bond is the strongest intermolecular force. Then, dipole. Okay, permanent dipole interaction. The last one is the London force, that is just because of the electron clouds of the molecule. Next question, which of the molecules are polar? Just you have to select one. F and F, if same elements, they will share the electrons in exactly in the middle. So their electrons will be there in the middle because same element, so they are not polar, non-polar compound. CCl4, here chlorine has greater electronegativity, so chlorine will try to take the bonded electrons towards it. Okay, that will make this bond polar. This chlorine slightly negative, carbon slightly positive. So this bond will become polar, but their polarity will get cancelled out because all stretching will be with same force. Like if you are pushing, or if you are pulling into these all four directions with same force, it will get cancelled out because this is a symmetrical molecule. Tetrahedral is the name of the structure and it is a symmetrical molecule. This chlorine is pushing this way, this chlorine is pulling in this way, this chlorine is pulling this way, and net effect will be zero because of the symmetry of the molecule. And NH3, it has got a lone pair of electron. Due to the presence of this lone pair of electron, they have no symmetry as well. This molecule is become polar. Okay, carbon dioxide, again you see Even though oxygen is more electronegative, it will pull the electrons towards it, but say it is present on both the sides, so the net pull will be getting cancelled out because of this symmetry of the molecule. SO3 again, SO3 you can see over here as double bond O in all in a planar shape. This also had got a symmetry. Because of this symmetrical molecule, their polarity will get cancelled out. Even though oxygen is more electronegative and it will pull the electrons towards it, but it will get cancelled out. So only this molecule, always you have to look for a lone pair. If there is a lone pair is there in the compound, then it will be polar. Let's see the next question. That is, which of the following metal do not liberate hydrogen? For that, you should know reactivity series of metals. You have to know about the reactivity series of metals. Here you see potassium, sodium, calcium, magnesium, aluminum. Here hydrogen comes. The one below hydrogen in the reactivity series, they are weaker than, they are less reactive than hydrogen. So they cannot produce hydrogen gas from any of the acid. Exemptions are other, but you have to remember this is the general rule. So if any element below hydrogen, they are unable to liberate hydrogen gas when they react with an acid. Let's see the next question. Now, which substances are each other's constitutional structural isomers? When you look for the structural isomers, isomers are the molecules will have same molecular formula. They will have same molecular formula. But different structures. Let's see formic acid and acetic acid. Formic acid is HCOOH. Acetic acid is CH3COOH. When you look at the number of carbon, 1 carbon, hydrogen is 2, oxygen is 2. Here carbon 2, hydrogen 4, oxygen 2. Not same molecular formula. They are having different molecular formula. When you look for the last one, acetone. Acetone is CH3 CH3. Okay, so in acetone, 1, 2, 3 carbon, C3, H will be 6, and there is 1 oxygen. Okay, this is the structure for acetone. Ethanol, when you look for ethanol, that is C2, H5OH. So when you count the total number of carbon, 2, hydrogen 6, and oxygen. So they are not having same molecular formula. Whereas for ethanol and dimethyl ether, ethanol, the formula all means alcohol, eth means 2 carbon. Okay, so ethanol 2 carbon, all means you will have OH, and the other elements will be hydrogen being attached here. So the formula for ethanol is C2H5OH. When you count carbon, carbon will be 2, hydrogen total 6, and oxygen 1. Dimethyl ether. Dimethyl ether is either with oxygen in the center. So CH3 or CH3. This compound has 2 carbon, 6 hydrogen, and 1 oxygen. So you see here, they have same molecular formula. So among all of these, this is the only one with same molecular formula, and their structures are different. Okay, so the answer here is this one. Now, how you can answer these type of questions? How many moles of KOH can be found in 500 centimeter cube of 0.5 mole per dm cube KOH solution? First of all, you should know if there is volume and concentration, number of moles can be found by number of moles is equal to volume times concentration. Okay. Now, volume is 500 centimeter cube, but here it is in dm cube. So you must divide this with 1000. So number of moles is equal to 500 divided by 1000 times 0.5. When you do this calculation, you will get 0.25 moles. So that's the answer here. Let's go with the next question here. How many moles of sodium chloride can be formed when 0.5 moles of sodium reacts with 2.5 moles of chlorine gas? You see the ratio, 2 moles of sodium combines with 1 mole of chlorine, 2 moles of sodium chloride. So if you have 0.5, okay, 2 half 1, 0.5, half of that is 0.25. 2 combined with 1, so 0.5, half of that will be there. To react with chlorine, 0.5 moles of sodium will react with only 0.25 moles of chlorine. That would produce 0.5 moles of sodium chloride. 2 to 0.5, 0.5, that's all. But we have 2.5 moles of chlorine. We are taking only 0.25. The remaining will be excess. Okay. So from 2.5, we will just take only 0.25. Okay. 2.25 will be excess. I mean, to react with the 2 moles of sodium, we need 1 mole of chlorine. So if you have 0.5 moles of sodium, you need half of the amount, that is 0.25. That will definitely produce 0.5 moles of sodium chloride because this same amount here 2. So the answer for this question is here. Okay. Now let's see the next question. That is 0.4 moles of ammonia dissolves in 150 grams of water. What is the percentage by mass in percentage composition of the solution? The molar mass of ammonia is 17 grams. Let's change this into mass, 0.5 moles of ammonia. You remember the triangle, that is number of moles is equal to mass over molar mass. So we need to find mass. Mass is equal to number of moles times molar mass. So it's 0.4. Okay, molar mass of ammonia is 17 grams. 0.4 times 17. We get the answer 6.8 grams. If you have 6.8 grams of ammonia, total amount of water is 150 grams. They are asking percentage composition, right? So percentage composition, mass over mass, 6.8 over mass of water, that is 150 grams. So 6.8 divided by 150 times 100, that will be 4.53. Okay, this is 4.53 percentage. Now let's see the next question. Which of the following compound would liberate 1 mole of hydrogen gas when 2 moles of it reacts with 2 moles of sodium? You have to remember this equation. When any of these acids, only we have formic acid, that is HCOOH. Okay, acids would react with metal, okay, that would produce hydrogen gas. Any acid, organic acid, or like inorganic acid, that would react with the metal sodium or any metal, that would produce hydrogen gas. Okay, 2 2 2, that is the balancing number. So 2 moles of acid reacts with 2 moles of sodium, produce 1 mole of hydrogen. These two we are putting to balance the equation. Balancing equation, you have to know. I'll be explaining you in another video maybe. Now another equations you can see here for acetone. Okay, acetone CH3 COCH3. This will not react with sodium metal. Propane, no reaction. Okay, butanone, methanol, no reaction. You remember only organic acid or alcohols. Okay, these are the two groups of compounds that can react with metal sodium usually. Now, a pH value smaller than 7 would be shown by this solution. Smaller than 7 means acidic. Okay, so the question is which one of these solution would be acidic? So potassium sulfate, that's actually a salt from strong acid and strong alkali, so it will be completely neutral. Glucose is neutral. Sodium acetate. Sodium acetate will form CH3 COONA. This is sodium acetate, which would ionize to form CH3 COO minus plus Na plus. So this CH3 COO minus can react with H2O in aqueous solution. You can form CH3 COOH plus OH minus. So formation of OH minus, this will become basic. Okay, they are asking for acidic. Ammonia, that is also a basic solution. Then ammonium chloride. Ammonium chloride is NH4Cl. When it ionizes, it will form NH4 plus plus Cl minus. These NH4 plus will form an equilibrium. Here, this is an equilibrium. A reversible reaction will form with H2O, that will form NH3 plus plus H3O plus. Actually, this H1H plus will be going out. So this H3O plus or H plus formation, that is making the solution acidic. So the answer here is acidic. Ammonium chloride is the answer. Okay. Now, the last question here. Rate of chemical reaction, you have to select one. Always decrease with decreasing pressure? No. It depends on the reactants. If there are more gaseous reactants, if you increase pressure, rate of reaction would increase. Okay, increases with the decreasing pressure? No. It will increase with increasing pressure if there are gases. Can be increased by using a catalyst. You have to remember catalyst. These are the substances which is used to increase speed of the reaction. Catalysts are the substances which, when they are present in the mixture, they will speed up the reaction, but they will not take part in the reaction. So the definition of the catalyst says they are the substances that would increase the speed of the reaction by showing easiest path for the reactions. Okay, decreasing with increasing concentration. No, if you increase the concentration, there will be more particles, so the rate of reaction would increase. So this one is the answer here. Catalyst would increase the rate of reaction by showing a easiest path for it. So that is our question number 20. Now we will be seeing, we will go with the sample 2, inshallah, later on.